So there are three main types of radiation that we're going to look at that are primarily associated with radioactive decay. They are alpha particles, beta particles, and gamma rays, which we're going to look at in turn over the course of this video. So first up are alpha particles. Now, alpha particles are basically helium nuclei, so 2 protons and 2 neutrons. Because they don't have any electrons, their positive charge makes them highly ionizing, by which we mean they easily remove electrons from other species. And they're really quite heavy, so they don't travel very far and aren't very penetrating, by which I mean they don't pass through things. They're absorbed by a few centimeters of air or stopped by a piece of paper. This means that they can't pass through your skin or your outer tissues. However, they can be very dangerous once they're inside your body, as they can't escape. They're generally emitted by the heavier elements, for example, the actinides, by the heavier elements, for example, the actinides, decaying down to and in this case here, 235, and spitting out an alpha particle. Next up, we have beta particles. Beta particles are basically high energy electrons, so they're negatively charged and they're traveling at almost the speed of light. They're much lighter than alpha particles, and so they travel a lot further and are more penetrating. So now if we want to stop them, we need to use a 5mm sheet of aluminium foil. They ionize other species by knocking out electrons and breaking chemical bonds or forming radical species, which are quite harmful. Although they are less ionizing than alpha particles. They're generally emitted by neutron-rich elements, as neutrons are converted to protons during the course of beta decay, and in doing so we change the element, as the element is defined by the number of protons. In this decay scheme at the bottom, we've got an isotope of sodium, sodium-24, decaying to magnesium-24 and spitting out a beta particle. Notice that the total number of protons and neutrons doesn't change, it remains at 24, although we are changing the number of protons. We've gone from 11 in sodium to 12 in magnesium as we spit out that beta particle. Last up are gamma rays. So gamma rays are high energy electromagnetic radiation, the highest energy electromagnetic radiation we classify. They've got a very, very short wavelength and are very high frequency. But because they have no mass or charge, they are the least ionizing. They are, however, very penetrating, so they will pass straight through a human body. Often are emitted alongside alpha or beta particles to rid the nucleus of excess energy following an alpha or beta decay. So if we look at this decay scheme at the bottom, we've got nickel 60. This little asterisk thing here means it's excited, it's in its excited state, and it will want to get rid of that energy to become the stable nickel 60 atom. In doing so, we will spit out that energy as a gamma ray. So on this slide, we've got a nice little summary of what we've learned so far. So we have our three types of radiation, alpha, beta, and gamma, and what their structure is. So an alpha particle is a helium nucleus, beta particle a high energy electron, and a gamma ray is an example of electromagnetic radiation. Their charges, well, an alpha particle has 2 protons, 2 neutrons, so it's got a charge of +2. A beta particle is an electron, so negatively charged, and a gamma ray has no charge because it is electromagnetic radiation. As we can see, gamma rays are the most penetrating, followed by beta particles, followed by alpha particles, although in terms of ionizing ability, alpha particles are the strongest, with beta being relatively weak and gamma very weak. So in terms of their general hazard, alpha particles are pretty harmless unless you get them inside you. So what you don't want to do is swallow anything or ingest anything that is an alpha emitter, because it will damage your cells and DNA inside your body. Beta particles, well, they have potential to pass through your skin and so can damage cells and DNA at close range. Gamma rays are pretty harmless provided you're far away from them. However, if you're very close to the source of this radiation and are exposing yourself to a lot of gamma rays, that can be quite dangerous.